Hi, everyone. Ramesh Radhakrishnan from VMware. And I lead a team called AI Platform and Services, Solutions. And what I'm going to talk about in this session is basically a lot of the use cases that we covered in some of the other sessions, how we are actually running it internally at VMware. So I'll cover some of the use cases that we built internally. And all of this we built and started building even before large language models were in existence. We use language models, and then I'll talk about some of the platform capabilities that we have built for other teams to also enable them to build some of these use cases as well. And then I'd like to summarize a few key takeaways so that other customers or organizations that are on the same journey as us can learn from our experiences. So, when we talk about all the different use cases, today, large language models is pretty basically a hammer, and all the use cases are basically nails, because large language models are able to address a wide variety of use cases without much modification, right? So that's the beauty of large language models. So one of the key use cases is content generation. And again, this is what large language models have been trained for. And it's not just text, but also multimodal capabilities with like images as well and videos. So I don't know if you've seen Sora that was announced this week. I think there's so many things happening; it's hard to keep track. But yeah, it's amazing what it can do. When it comes to question and answering, everyone's always looking to see how they can do better search. So it's not just getting answers from different sources, but also being able to synthesize the answer from all these different sources and not having to go read multiple documents to get your answer. We've talked a lot about code generation, and again, code generation is not just for traditional programmers, but also for administrators who are using things like YAML or Terraform. So the use cases for this are pretty wide. And then finally, you're going to see a lot of agents come into the picture, where you're going to leverage multiple of these use cases and chain them together, or build a complicated solution by taking all of these and combining them into doing more useful things. So the stage for this is pretty exciting, and I think it's just going to keep growing. So obviously, all these organizations, including VMware, want to take advantage of generative AI, but we have to be cautious in how we go and tackle these different use cases and demand from our teams. Again, we have a policy, internal AI policy within our company that lays the ground, the guidelines for how some of these generative AI capabilities can be used, right? So one of the ways that we do this is by taking a cloud smart approach. We've talked about cloud smart in the past for traditional applications. When it comes to AI applications, what this means is that we're going to leverage these large language models that were trained on the public cloud, right? And now they are open source, and they have a permissible commercial license, which means we can use it to build our own use cases, right? So by doing this, we are not burning millions of carbon, or impacting the environment by running GPUs when we don't actually need to do it, right? So once you bring these large language models on-prem into our own infrastructure, we can definitely use it for multiple use cases. And then we're able to control what the performance of these models, and pick the right latencies or performance that we need out of those. So that allows us to, again, do it in a very sustainable manner, right? So we talked about, we don't really need a 70 billion parameter model or 100 billion parameter model for a lot of the use cases, where some of these smaller models that are fine-tuned or specialized will be able to do that same task. So as we went down this journey, again, some of the use cases that we prioritized were based on the demands that we got from our internal teams. The first one, again, was improved documentation search. So I don't know about everyone here, but there was a survey that was done which showed that around 40% of your time is actually spent in looking for information. So whether if you're a programmer, you're up on Stack Overflow, or you're a product manager and you're looking through Google for finding the right content that you need. So we worked with Stanford and built a domain-adapted model for VMware, which enabled us to, in the top 5 recall, we were able to get about 5.5 times better performance than the traditional search.
Ramesh, Ken Collins, when you say 5.7 better, is that compared to traditional lexical or tokenized search or other embedding models like OpenAI or Cohere?
No, this is compared to just keyword search. So yeah, so it was better than that. And then we domain adapted this model on VMware Lexicon so that we were able to get much better results. So compared to state of the art, so we leverage the Colbert model from Stanford. By adapting that for our own use cases, we were able to even improve performance over that.
I'm curious, and the product or this use case might not be fleshed out fully, but how have you adapted the product to talk to, say, different versions of the documentation? Because things in the past, obviously, there might be similar phrases, and you might be pulling a match from vSphere 6, 7 or something, and you really want 8.
Yeah.
How have you addressed that? Is there a different interface or a selector or?
Yeah, so because we're using neural search, it's supposed to have context, right? So there's going to be references to what version that you're using, so then it can pull relevant documentation based on that.
So that you see this being embedded actually in, say, the vSphere console, for example?
Yeah, so we don't... oh, you mean, no, we could do that. So the way we build the service is that it could be leveraged by our product teams so that, if they wanted to embed it into the products, they could use it because we built this as a RESTful service. But I thought your question was, maybe I misunderstood, is if a user is asking a question about a specific vSphere version, how does it pull the right information and not go to an older version or a new version?
Yep.
Okay. Yeah. So when you're asking the question, if you don't specify what version it is, then it'll obviously pull kind of the latest information. But if there's context around which version it was, and it's able to gather that information, then it'll go to the right documentation.
Yep.
Sorry, go ahead.
What kind of holes did you find in the documentation? I mean, this is kind of because data is only as good as it is, and I know from working at VMware there was lots of holes, especially depending on which version we're talking about.
They've improved all of it.
Yeah.
Right. So did you guys have to improve the data so the searches came back better?
Yeah. So we do have to. So we're not going and improving the documentation per se. We are using the documentation as it exists. But again, there's a lot of. It's not just the docs. That is a big part of our corpus. But we also pull information from Confluence pages for internal searches and then external blogs. So all of your content is all being indexed and used in our search. So when a user asks a question, it's going to look up the right passages or information from that query and then pull it, whether it's either from the docs or from other external sources as well.
Seeing all those blogs we were paying off for somebody.
Yes, it is. It is being
or adding an extreme bias to.
Well, yeah,
right? So that's actually another good point. So what does the data pipeline look for that? Because obviously these documentation, blog posts, internal KBs, all these other sources are updating relatively frequently.
Yes, they will. So I will definitely cover that. I have a slide which talks about how this is implemented in production. Yeah. So then finally, it's developer agility. Again, there's, we did surveys. A lot of our programmers want a coding assistant. So we want to be able to provide them a service that's being run internally so that all our code stays within our own firewalls. So yeah, let's dive into the documentation search, right? So we call it VMware automated question answering system. So it's not just pure search. You can actually ask a question and you get your relevant answer, right? So you don't want to just go through document browse and then try to figure out what you want. So as someone brought up, there's tons of documentation, and it just keeps increasing. So what we've done is, again, build information retrieval system that's based on language models. Again, you could do this today with large language models, but there's going to be still a lot of engineering to actually make sure that you are getting the right answer, you have the right guardrails, and the context is being addressed properly. We worked on this starting maybe 2.5 years ago, and we worked with Stanford to use, at that time, the state-of-the-art language model, which was Colbert. And then for question answering, we've gone through multiple different models, again, improving it over time, right? So at the very, basic, think of it as having, 4 different steps. So one is once you get a query, you clean the query, you have all your data that's being indexed and stored in a database, and then you pass it on to the Colbert model, and then it basically pulls the relevant documents from your database. And then it gets passed to a question answering system, which highlights the relevant passages and then send it back to the user, right? So easy peasy, right? So yeah, as a science experiment or a research, this was fairly straightforward. It's not fairly straightforward. There's a lot of experimentation that was done. There was a lot of fine tuning in order to get better than state-of-the-art results that we wanted. So once we did that and we wanted to put in production, that's where it became a lot more complicated, right? So the part that I just showed is what you see here on the right. You have your information retrieval, you have your preprocessor and your question answering. But then, Ben, you brought up all the other part about updated documentation and how do you handle indexing and whenever those documents change. All of that is what you see on the left, right? So it starts off with content gathering, right? So you can have a content authoring system like DocWorks that pushes it directly into the corpus, but there's also a lot of other documentation that exists that we want to use, right? So we have to go crawl those using a crawling service, scrape the websites, get all that information, and then update it into the database, right? And again, that is not easy. Each of these different sites are fairly different, so it becomes a pretty complicated task to do. And then once you have that information, it gets pushed into then the content management service. Basically looks at all the information that you have and then pre-process it. And I think, Ben, in your session earlier, you talked about removing, converting it to Markdown, removing some of those useless information. So we do all of that. We do that. We also have to account for, like spelling mistakes and large complex words. So, we have our own preprocessor that does that service. We have to tokenize this so that we can handle out of vocabulary words. And then again, once you have all this cleaned up information, it goes into the index management. So in index management, you create new indices based on all the data that you've collected. And again, this is done on a daily basis, right? So we basically go and crawl all the information, all the documentation, and then we do it in a manner where we look for updates, and then we just keep updating the indices and the documentation based on that. And then once you have, again, there were optimizations that were done around caching, so that you don't have to go back and do a search again if that search was already asked in the past and you have that information in your cache. So Redis helps over there. We do leverage GPUs as well for the indexing. And again, that's spun up on an on-demand basis so that you're not consuming GPU resources when you don't need it.
So Ramesh, if you were to do this today, you'd use large language models, RAG kinds of solutions to do this sort of thing.
So
would you still do this more complex type of approach?
Yeah, so this is question and answering. So we've taken this and actually use it for a RAG use case. So we've built a conversational engine that leverages this. So that uses a large language model, and then we've done tricks to increase the context size for that. But yeah, so in that case, we don't actually use a vector database. We just make a call to this Wakwa API, and then we get the information that we need, and then you answer that question.
Okay, thanks.
So a query then, would you consider, or are you considering, or maybe you can't talk about it, everything on the kind of left-hand side as a service as part of the private AI? Because a lot of organizations are trying to solve these challenges around crawling, updating indexes, the database infrastructure. Everything that you see there is largely complex and there's really not too much to do about infrastructure. Do you see that forming part of your portfolio?
We absolutely do. So we are, so again, this is the initial offering. We've done this. We know how to do this. So we're looking at how can this be packaged in a more generalizable form so that other customers can use it. And we'll add it as services on top of private AI.
Fantastic.
And then we're also working with our professional services team so that some of these can be even offered as services for customers that want to use professional services engagement as well. So we talked about some of the use cases. So we talked about question and answering. We talked about the coding assistant that we build for our internal employees. So let's talk a little bit about the tools itself, right? So there are teams within, again, when we started, our primary audience and customers were data scientists, right? These were folks that were leveraging machine learning models and building models to solve different use cases. So at that time, there was a request for a few GPUs, but most of the work was done on CPU. So we built this platform which enabled these users to request the compute that they wanted. We gave them the developer environment that they wanted. It was either Jupyter notebooks or Visual Studio, and then they could get started on their model building and experimentation, right? And then ChatGPT came and it turned everything on its head, right? So now you have all these software developers that are being empowered to build applications. So obviously we've had to scale up our GPU capacity. There's a lot more requests for GPUs, but again, that same platform is being used to handle both of these types of use cases. Now, for a lot of these software developers, they don't actually need access to a computing environment or a developer development environment. They basically just need APIs, right? So they're used to working with APIs. So we've built a service where we host a lot of these large language models, and we provide access to them so that they can get started. And then we do this in a very iterative fashion where we add new capabilities to the platform. Again, we have to kind of anticipate based, for example, as these new models come out, we're going to expect that there's going to be demand for it from our customer base. So this is kind of what the model looks like. What the platform looks like. We've kind of created a GPU pool resource so that we're not, these GPUs are not being hijacked by any one user. As soon as a user is done, it gets put back into the pool. And then, all these environments that we talked about, the developer environment, the coding use cases, and the large language model APIs, it's all running on top of this common platform. So one of the key things, again, since we are running out of time, we talked about the data. This is obviously going to be a bottleneck for a lot of these AI use cases. We didn't really touch on that a whole lot. But again, that's something that you want to pay attention to, right? Again, using a common model and standardizing on a platform will enable organizations to offer services to all their end users. So you don't have different teams where these machine learning engineers are trying to do the same thing that somebody else has already solved. So it's critical. We find that moving forward for these AI teams and the infrastructure teams to work together. So you might have the best models, but if you don't have the right infrastructure and you're not able to scale the infrastructure to handle that workload, then no one's going to be using that. And then vice versa, you might have really fast infrastructure, but if you don't have good AI models or services, then that's really not going to be the best use of that. So you could really start small with some of these open source models and identify the KPIs and what you want to solve in terms of business problem. And I think that's the best way for organizations to get started. That's how we did it. Thank you.